Alright, so when you're talking about the scientific method, you know, first you make an observation, then you ask a causal question, then you make a hypothesis, and then you get to the point where you have to collect data. And you have to know what kind of data you're collecting, because you need to know what kind of experiment you're going to run. So there are two main types of data. There's quantitative data and qualitative data, and the difference between those two is what we're going to talk about today. So we don't have much in the way of a board, so you may be visual learners, so if you have any questions or you need me to slow down, just let me know. So, first of all, scientists, right? They like to come up with these big words to make you feel like you don't know anything, because I think it makes them feel special. So why don't we, instead of me just telling you the definitions, why don't we think about this for a second? So quantitative comes from the word quantity. What does that mean? Amount. Good. Exactly. So when you have quantitative data, you're taking a quantity of something. It's a numerical data that you're taking. Like the mass of something would be quantitative data because you're getting a number of grams. And quality, what does that mean?
Like in this context?
Yes, that would be.
I don't know, aspects of?
Right, good. So if you're observing something, or you have the aspects of it, then you're looking at maybe the color of it or the texture of it. So you're describing it without any kind of numbers, right? So why don't we look at some examples of that? I mean, for example, if you have, let's say you're doing an experiment and you have to figure out what kind of chemical is in there, and you know that if you mix these two things together and it turns blue, then you have a certain type of chemical in there. So what kind of data would you be collecting in that case, quantitative or qualitative?
Qualitative.
Right, good. And now let's look at a case where it could be both. Like let's take acidity, for example. You might know that substances can be either acidic or they can be basic, which is the opposite of acidic. And so you can either test, there are many ways to test this. There are fun indicators like cabbage juice and like weird things like that, where you can see if something is acidic or basic just by it changing colors. And that would be, what kind of data would that be?
Qualitative.
Right, good. But you can also, if you've heard of the pH scale, which is a scale from 0 to 14 on how basic or acidic something is, you can get an actual number for how acidic or basic a substance is. Like you can have something that's 2.5 and you know that's very, very acidic, or you can have something that's 10.3 and you know that's much more basic. And so what kind of data would that be?
Qualitative.
Right.
Quantitative.
Right, good. Yeah. So it's a little tricky. You have to make sure you pronounce it correctly, because the couple letters make a big difference, and then you would get, docked off on a test or something. We wouldn't want that to happen. So now, why don't you, for a second, take a second and think about it, and I want you to each come up with an example of one of the two things. If you can. Maybe.
Okay. If you weigh the mass of something, that's going to be quantitative, or take measurements of it. Its length.
Right, good, length. Yeah, that's a good one. Can you think of maybe another qualitative one?
If you were to record the traits of something, its texture, taste, using your senses.
Right, taste. Good. The only thing though with science is that you never ever want to actually taste something.
Smell.
But acid is delicious.
Okay, we're gonna watch you in lab. But yeah, you can definitely smell something as long as nobody tells you not to. Yeah, you waft it. You don't actually just smell it, because that can be dangerous too. Yeah, and I think if you guys are completely clear on that, that's pretty much it.